Okay, in this lecture we're going to talk about determining domains and ranges for a relation given their graph. And we're also going to look at how do we determine whether this relation is a function or not. Because graphs are a little different. We've talked about points like this, and this one's not too hard. If I look at the domain of this one, then we just look off the graph and we see what x values are being used, and we see that -2 is being used and 4 is being used. So it's actually -2, 4. Now for the range, all right, we just look and see, well, what are the y values that are being used? Well, we have 0 and 3. So we usually put the smallest one first. Right, and so that would be the domain and the range. Now, we've got to ask ourselves, is this a function? Now, remember, a function is a relation in which there are no two ordered pairs with the same x value or first value. Notice that these two ordered pairs have the same first value as well as does this one. So this is not a function. And that gives us a clue on a rule that can apply to a graph to determine whether or not a relation is a function, and that's what's called the vertical line test. So if I can put a vertical line down through the set of points anywhere and pick up two of them or more than two of them, then it's not going to be a function. This is called the vertical line test. All right, so if I can put a vertical line anywhere through the relation, through the points that make up the relation, and find that I can pick off two or more points, then it fails the vertical line test and it's not a function. Right, if you look at this one here, we're going to say that this one continues on. And you can see here, well, what is going to be the domain? Well, you can see here that all the x values are being used because this continues to go up. And so this would be all real numbers. And the way we do all real numbers is we use a interval notation, -infinity to infinity, with the curved parentheses here. Now if I look at the range, this is also going up. So all the x values are increasing. As the x values are increasing, all the y values are increasing, and down this way as the y values are getting smaller when the x values are going this way. So again, this is all real numbers. And of course, again, it's -infinity to infinity would be the range. Now if we look at this one, we do have captured in here, all right, some points. X doesn't go past this point here. A little hard to read, but it's actually a 5 there. And here, of course, is a -5. So our domain here is everything between 5 and -5. So we'll use a interval notation, and there it is. Now notice here, this is going from here to here. This is 2.5, so this is actually 3 here, and -3. And you'll notice that our range goes between -3 and 3. Now, is this a function? Well, clearly if I have a vertical line that goes anywhere down through here, it picks off 2 points. So this is not a function. Well, what about our straight line up here? Notice if I put a vertical line down anywhere through this, it only picks off 1 point. So this one is a function. And so a little clue for you, every non-vertical straight line like this will in fact be a function. Right, if we come down to this one, this is a parabola here. Right, now it's a little hard to see, but that actually, this point here is actually -2, 4. Right, now you'll notice that as far as x is concerned, we're going every direction in x here, this continues to go down, okay? And every x in this direction, this continues to go down. So we're covering all the x's here. So the domain is all the real numbers. Now the range, we have to be a little careful of, because notice it doesn't go any higher than 4, but it goes down here indefinitely. So it's actually from negative infinity, it's important to get the order right, up to 4. The smallest one always goes on the left of the interval. So it's negative infinity to 4. Now, does it include 4? Yes, it does. So this would have to be a square parentheses right there to include 4. Right, so that's how we can pick off the domains for a graph. Now, is this one here a function? Well, if I put a vertical line anywhere down through this, it's only ever picking up one point, so yes, it is a function. Yes. Okay, so the next trick, of course, is it possible, all right, to actually determine if the following are functions and find the domain and range. Right, so number one, what if I have something like y equals 2x take 5? Right, well, this is a linear function, as we've seen, and so as we looked at this particular case here, this will in fact be a function, yes, and the domain is all the real numbers, and the domain is all the real numbers. Okay, so linear functions are really pretty good to deal with. Right, number two. Right, what about y equals, let's have a look here, x squared plus 3. Right, so for this one here, of course, this looks very similar to what we had down here. It's a parabola of sorts here. Now, what is going to be the domain and range, and is this a function? Well, if it's parabolic, yes, it will be a function for the same reasons as this one down here was a function, just that this one is an upright parabola like so. Right, now how do we determine the domain? Well, we say to ourselves, and this is the trick to finding these, is there an x value here that we can't square and add 3 to? Well, we can square every real number and add 3 to it, so clearly the domain is simply going to be negative infinity to infinity. Now we have to ask ourselves, well, what are the values? Are there any values of x that we can't have? Well, we answered that, but now we look at y. What about y values? Well, as x gets larger and larger, doesn't matter whether it's negative or positive, we square it, it always becomes positive and then add 3 to it. So if we think this through a little bit, if I square a negative number, I get a positive 1 and I'll add it to 3, so I get more than 3. So the smallest number I can square and add 3 to get the smallest number is, of course, 0, because 0 squared is 0, and add 3 I get 3. So the largest value, the smallest value I can get will be 3, because every other value I'll be adding something to 3 and it'll be getting bigger. So this is how we reason this through. Again, if x is positive or negative, I square it, I get a positive number, so when I add 3 I'm getting a number bigger than 3. If I just put 0 here and square it, I get 0, so I get 3, so this would be the smallest number. So the range is going to be from the smallest number, which is 3, and including 3, we're allowed 3, and that will go to infinity, so that'll be the range. Okay. All right, let's look at another one. Let's suppose we take a look at x is equal to the absolute value of y. Now, straight away, remember that if I have an x value of 3 here, I could have a y value of -3 or 3. So I could include 3 and 3 as an ordered pair, and 3 and -3 as an ordered pair. Okay, because if y is 3, I get x is 3. If y is -3, the absolute value of -3 is +3, so I get 3. So this is not a function. Okay. All right. Next, what is going to be the domain of this? Well, what x values can we have here? Well, we obviously can only have positive numbers, because no matter what y is, it's going to take the absolute value of it and it will get a positive number. So the smallest number I can get is 0. After that, I can get anything. And what is the range? Well, of course, the range has to do with what can the y values be here. Well, they can be anything, because when I take the absolute value, I'll get a positive number, so that'll be fine. So that will be all real numbers. Right, so that's how we do that. All right, what about number 4? All right, suppose we have y is greater than equal to -x. All right, so in this case here, of course, we have y is equal to is greater than or equal to -x, then y is greater than all the negative of x values. So let's take some values here. Let's suppose I take x is -1, okay? Then what values of y are greater than -1 and greater than equal to -1? Well, any y values, for example, 2 is greater than -1. 3 is greater than equal to -1. So I've got ordered pairs here that work, like 2, -1, 2, all right, -1, 3. And so I've got 2 ordered pairs. In actual fact, there's going to be an infinite number of these, because this is really a region, okay, a whole bunch of points. And of course, we just got to show 2, so this is not a function. All right, so that's not a function. What about the domain? Right, well, the domain is what are the x values that we can possibly have. Well, I can take any y values here, all right, up to -1 would satisfy this, okay? And because for this particular one here, but of course we can have any x value here. All right, we can choose any x value here and take the negative of it, okay? So clearly that would be our domain. Now what about the range? Well, depending on what x value I choose, there's going to be a multitude of y values that will be greater than or equal to it. And so clearly we're going to be able to get all of these, okay? All right, so that will be the range. Number 5, let's suppose I have y equals 3 over x plus 2. Now again, we ask ourselves, what values of x can't we have? And so for the domain, I look at this and I say, this is a rational here, so I'm very interested in what happens in the denominator. Notice that if x is -2, all right, I would have 3 divided by 0, and we can't have that. So consequently, I can't have -2, so it's all x except, right, x equals -2. So how do I write that in the interval notation? Well, negative infinity to negative 2, but I don't want to include negative 2. And we'll join that with negative 2 to infinity. And of course we have the round brackets to say we're omitting negative 2. Right, now how do we go about working out the range for this? All right, well, there's a few things. You could think it through, but here's a little technique for you that you could try. So here's our little trick here. Right, what we do is we say, all right, let's solve this for x. Okay, so what we do is we multiply both sides by x plus 2, all right, and divide both sides by y, so I'd end up with this. And this implies, so I've cross multiplied really, and this implies that I have x is equal to 3 over y take 2. Now I ask myself, what values of y can't I have? Well, I can't have y equals 0, so the range is all real y, real numbers y, I guess we could put, all right, numbers y except y equals 0. So how do we write that? Well, it would be negative infinity to 0, not including 0, union with 0 to infinity. And that would be our range. Now, is this a function? That's a very good question, isn't it? Now, is that a function? Well, we've got to ask ourselves this. We have this, if I take an x value, all right, can I get two different values for y? Okay, that would mean that I'd have two ordered pairs with the same x value. So notice that if I take a 1, I'd get y as 1, and there's nothing else I can get. If I have x as 0, I get 3 on 2. There's nothing else available. So I'm only getting one y for each of those x's. All right, so in other words, this is a function. All right, so this is a function, yes. All right, so that's how we go about trying to find domain and ranges, looking at graphs and just looking at the equation.